Okay, let's prove this by induction. So we know the story here. Case, or not case one, but step one, prove the first case. Prove case n equals 4 is true, i.e. 2 power 4 is greater than or equal to 4 squared. 16 is greater than or equal to 16, so that's true. Case 2, part 2, assume case n equals k is true, i.e. 2 power k is greater than or equal to k squared, where k is 4 or more. Actually, I probably should really write that down. This is part of the statement too, but anyways, you get the idea. Required to prove case n equals k is true, i.e. 2 power k plus 1 is greater than or equal to k plus 1 squared. So the way you do this is you start from 2. So for these inequality proof by inductions, you start with 2 and you start with the bigger side here, the 2 power k. And you wonder what you would have to do to get this 2k to become 2 power k plus 1. So that is, you multiply it by 2. So that becomes 2 power k plus 1 is greater than or equal to 2k squared. Now, we're required to prove that 2k squared is greater than or equal to k plus 1 squared, because if we can prove that, then we've proven 2 power k plus 1 is greater than k plus 1 squared, which is exactly the thing we need to prove. So let's see if we can do that. Is 2 times k squared greater than or equal to k plus 1 squared? Well, let's expand. That's k squared plus 2k plus 1. That means k squared, if I take everything to the left, k squared minus 2k minus 1, is that greater than or equal to 0? Complete the square here, k minus 1 squared minus 2, isn't it? Is that greater than or equal to 0? Or maybe it might be clearer to say, is k minus 1 squared greater than or equal to 2? And the answer is, this is true, since k must be greater than or equal to 4. So the smallest that this could be is 3, you know. Or if you don't like that, you can take the square root. K minus 1 has to be greater than or equal to the square root of 2. Now there is a negative situation here, but there's no need to consider the negative because we're only looking at natural numbers. So we can reject the minus since we're only looking at n natural numbers, excluding actually 1, 2, 3. We're starting from 4. So that means that k has to be greater than or equal to root 2 plus 1. And remember, k is a natural number. That means that k has to be greater than or equal to 3. Root 2 plus 1 is 2.4. To be bigger than 2.4 and to be a natural number means you have to be 3 at least. And this is obviously true since k has to be at least 4. So when you put your 1 and 2 and 3 together. This is our last step. That means it's true when n equals 4, 5, 6, etc. There we go.